All right, so for our second objective here, what we're doing is we are solving a system, a linear system of equations with three variables by elimination. The next one's going to be by substitution, whatever. Let's do some elimination. And we've talked about this picture before as being matter and antimatter coming together, annihilating each other, where things are the exact opposite. And that, of course, is what you do with elimination, whether it's two variables or three variables. So let's just take a look at this for a second. So, well, you know, when we first started talking about system of equations, we graphed them and we found their point of intersection that way. So you saw how fun it was to graph a plane on a piece of graph paper. Imagine graphing three of those and find the point of intersection. Let's just not do that. So instead, let's talk about the elimination method. Okay, so in the elimination method, well, here, let's just take a look. Okay, so here is a system of linear equations with three variables, and I'll just throw the picture up here. Those are the three planes, and basically we are looking for the answer that is right here, the point of intersection. So you know from elimination with two variables that what you had to do was just add two equations together, or some multiple of two equations, to make one of the variables disappear. So if I look at these equations, maybe you notice that the z's down in the bottom two equations, one's -5 and the other one's +5. So if I just add those two together, let's just add those two. Ignore the top one, add just the bottom two. I would have 2x plus 2y. These would cancel out, is equal to 2. Okay, so I have an equation with x and y in it. In order to solve an equation with x and y in it, you need another equation with x and y, which means that what you would do is you would go back to the first two equations and try to eliminate z again, right? So you'd have to multiply the top one by 5 and the second one by 6 and add those equations together to get rid of the z, so you can have another equation to pair up with this one, so that you can solve the system with just x and y in it. Do you get the point here? Okay, so let me kind of outline this out in steps for you. So this elimination method, it's basically 3 steps here. So you're going to use the elimination to write a 3 variable system as a 2 variable system. Maybe you're getting rid of the z's like we did in the previous one, but it could be x's or y's, whatever's most convenient, okay? So you're eliminating them twice, right? So you have to eliminate the same variable from 2 different sets of equations. That might be equation 2 and 3, and it might be, again, equation 2 and 1, okay? All right, so then you have a 2 variable system that you have to solve for both of those variables. You might use substitution, you might use elimination, whichever is most convenient for you, okay? You solve it for both of those variables. And then you're going to have to substitute those two answers that you just got back into one of the previous equations, one of the original ones, so that you can get the remaining third variable. Okay? So we eliminate one of the variables from 2 different sets of equations so that we have just 2 variables. Now we solve that 2 variable system just like we used to, and we solve for both of the variables. Once we have those 2 numbers, we're going to stick them back into one of the original equations so we can find the third variable. Okay? So a couple things here, and that is, if at any point we solve as we're solving the system and we get a contradiction, like 0 is equal to 1, we stop. That means that there's no solution. All right? So there's nothing that you can do. There's no solution. All right, move on. Okay, if any point that when you're solving you get an identity, a true statement, like 0 is equal to 0, everything cancels out, then you have infinitely many solutions. And that doesn't mean that you stop, because there's a little bit more work to do. You'll see that coming up here in just a little while. Okay, as a matter of fact, that's what your challenge problems are about? Yeah. Okay. So, to help you through this system, because it can get pretty complicated here, we're going to letter each one of our equations. And whenever we letter, just take that same system of equations that we were talking about before. We're just going to letter them A, B, and C, just like so. Okay, so why don't you go ahead and pause right now and write down that system of equations that you've got. and label them A, B, and C. Okay, so now moving on, what we're going to do is we're going to write a tiny little equation, or a little expression that says, in terms of A, B, and C, what we're going to do to eliminate one of the variables, okay? So, for example, we wanted to, this is what we did before, we wanted to get rid of the Z. So a very easy thing to do is take equation B and add it to equation C, okay? So that's what I'm going to do. I'm going to list that out. I'm going to write down B plus C, and then I'm going to write down equation B, write down equation C, and I'm going to add them up, and I believe that's what I got before. Anytime I get a new equation, it gets a new letter. I call that one equation D. Now notice that everything is even in that equation. So why don't I just go ahead and take half of it? So I'm going to take half of D. I'm going to write that down. Half of D to simplify it. So I should have x plus y is equal to 1. Okay? There's a new equation. Let's call it E. Now you could have, if you wanted to be conservative with your letters, not called D anything, just saw that everything was even, take half of everything, and then just call that new equation that you got, x plus y equals 1, could have called that one D. Just saying, that's what you could do if you wanted to. Okay, so notice that we have an equation that has just x and y in it. We need another equation that just has x and y in it, but we can't use B and C together to get it because they'd match up with that one. So we go back, and maybe I use equation A and B together. Okay, so a combination on this one to get rid of the Z would be 5 times A plus 6 times B, right? So that's exactly what I'm going to do. I'm going to write down 5 times A. So I'm going to take the first equation times everything by 5. So I'd have 10x's minus 5y plus 30z is equal to negative 20. And then taking 6 times the second equation, I have 36x plus 24y minus 30z, so those would cancel, is equal to negative 42. Okay, so then just add up our columns. We're going to have 46x's, 19y's, and negative 62. Let's call that equation F. So it doesn't look like they have anything in common, so we can't simplify it any. So remember, the previous equation was, it was x plus y equals 1. So x plus y is equal to 1, and that was equation E. So now I'm going to do some combination to get rid of either x or y, right? I got a 2-variable system, just like something from the previous section or something. So let's see. The 19y is going to be a little bit smaller, so why don't we do a negative 19 times E plus F. That should do it. Okay, so that's what I'm going to do now. Is I'm going to take negative 19 times E, add it to F, so negative 19 times that equation E should be negative 19x minus 19y is equal to negative 19. And now just add up our columns. So we should have 27x, the y's cancel, is equal to negative 81. Now just divide that by 27, and we get x is equal to negative 3. We found one of our variables. Okay, so now we want to substitute it into one of the equations that have just x and y in it. Why not equation D? Because that one was the simplest, right? It has x plus y is equal to 1. So that's what we're going to do here. So negative 3, it's the x value, plus y is equal to 1. Just add the 3 over, so y's got to be equal to 4. Now we have 2 variables. We're going to take those and we're going to substitute it in one of the 3 original equations. Why not A? Those variables, are the coefficients, look like they might be a little bit smaller. Okay, so we're going to plug those 2 in for x and for y. So we get 2 times negative 3, the x value, minus 4, the y value, plus 6z is equal to negative 4. So simplifying here, I get negative 10, add that 10 over, you're going to get 6. So that means z's got to be 1. So our final answer should be written as an ordered triple, and that ordered triple looks like this. The x coordinate is negative 3, y coordinate is 4, z coordinate is 1. So what did you think? That was pretty fun, huh? It's quite a bit of work. So let's take a small little break here, and let's have one. Let's do another one of these things just from scratch. Another couple of these things from scratch with no little animations. We're not dependent upon PowerPoint to do this for us. We're going to do it ourselves. Okay.